Action. All right, guys, we're going to answer this question. We have a function h of x. H of x is equal to e to the 2x divided by x minus 3. Okay? I like to point out that actually that there's a discontinuity at x equals 3, right? There's going to be a vertical asymptote there, first and foremost, okay? Just in case I'm wondering, okay, critical points, I'm gonna throw that one away, all right? A vertical asymptote cannot be a critical point, okay? So if I want to find a critical point, I'm really looking for where h prime of x is equal to 0. Where's the derivative equal to 0? In order to find that, I need to actually know the derivative. So what is the derivative of this function? This function is a quotient. So I'm going to apply the quotient rule to differentiate it. So here we go. So the derivative of h of x is going to be, we say low times the derivative, low d high minus high d low over low squared. All right, so low, x minus 3, derivative of the numerator, derivative of e to the u is e to the u prime, so this is e to the 2x times 2, all right? Make sure you use the chain rule right there, okay? Minus high, which is e to the 2x, d low, the derivative of x minus 3 is 1, right? So linear function with slope of 1, all right, over low squared, so this is over x minus 3 squared. All right, let's clean this up a little bit. So we will have 2x minus 3, let's say 2e to the 2x, that'll look better. 2e to the 2x times x minus 3 minus e to the 2x, okay, over x minus 3 quantity squared, all right, and I can clean it up even further because I have two different factors of e to the 2x, all right, so I can say e to the 2x times, times 2 to the 2x minus 3, yeah, minus 1, yeah, all over, let's see, x minus 3 quantity squared. Let me make sure I didn't mess that up. That possibility does exist. Okay, all right, and so we're setting that derivative equal to 0, right? Okay, thinking about fractions. The only way you can get a fraction to equal 0 is if the numerator is equal to 0. All right, so I'm going to think of this. E to the 2x times 2 times x minus 3 minus 1 equals 0, okay? So let's think of that. The only way to get a product equal to 0 is if either this is 0, either this factor is 0, or this factor. That's a zero product property, right? So let's erase a little bit right here. Let me make some space. I always run out of space writing really big. Okay. So, adios mío. Okay. So we can say either e to the 2x equals 0. This is not going to happen. That's an exponential function. It has a horizontal asymptote at 0. All right, but we can say 2 times x minus 3 minus 1 equals 0. Right, so that's 2x minus 6 minus 1 equals 0, or 2x minus 7 equals 0. 2x equals 7, and x equals 3.5. All right, so x equals 3.5 is a critical point. All right, the derivative is 0. I could say that it is a local maximum or a local minimum. All right, to summarize how we did this problem, you need to find the derivative of the function. The function is a quotient, so you need to use a quotient rule. Set that derivative equal to 0. All right, then use algebra to find what value of x makes the equation true. Okay.